Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
A small game on the Raspberry Pi Pico to test your reflexes. Let's get into it. Hi, and welcome to RoboCraze. My name is Shiv, and this video is the fifth in our series where I am teaching you how to program the Raspberry Pi Pico microcontroller using C with the help of a Raspberry Pi SBC. In this video, we'll make a small game to test your reflexes with 4 LEDs and 4 buttons. And whichever LED lights up, you have to press that corresponding button in time before it times out. So let's get started. So let us begin by setting up the circuit. I have over here 4 buttons and 4 LEDs. I have connected all the ground pins of the LEDs to this rail on the breadboard, and the other pin of the LED to the empty pin in between the 2 button pins. So as you can see over here, in between the 2 button pins there is an empty pin. I have connected the LED over there just for the purpose of aligning them with the button properly. Once this is done, I have taken a current limiting resistor and connected it to the rail where the LED grounds are connected and connected it to the ground pin on the Pico. The ground pin I am using here is 3rd from the right on the top. You can see this in the pin diagram on your screen. Now on breadboards like these, the rails are not shorted throughout. The first 5 are shorted together and the next 5 are shorted together. But these 2 sets of 5 are not shorted to one another. So for that, I'll take a jumper wire and connect these 2. Now I'll take 4 more jumper wires and connect them to each of the 4 LEDs. For the LEDs, we'll be using GPIO pin numbers 16, 17, 18 and 19. So the LEDs will be connected to GPIO 16, 17, 18 and 19. Now I'll move these out of the way and connect these up. So pin number 16 is the rightmost pin on the top, and then sequentially from there we have 17, then the ground pin where a resistor is connected, and then we have pins 18 and 19. And with this, our LEDs are connected. I'll now connect the buttons. So for the buttons, we'll be using pin numbers 12, 13, 14 and 15. So I'll go ahead and connect one end of the button to these pins. So we have each of the 4 buttons. And then these go to each of the 4 pins. So GPIO number 15 is the rightmost on the bottom. So we go sequentially from there. So we have 15, 14, then we have a ground pin which we'll be using in a bit, and then 13 and 12. The other end of the button will go to the ground pin because we'll be internally pulling these GPIO pins up, and whenever we press the button, they'll be pulled down to ground. So the other terminal of the button will go to ground. So I have these 4 jumper wires here. And we can take the ground rail on the bottom of the breadboard itself. So these 4 can simply connect over here. And then I can take one more jumper wire and connect it to ground. This ground pin that we left in the middle over here, next to between pin numbers 13 and 14, we'll use that. And I'll connect it to the corner so that it stays out of the way. And I'll pull these also a little bit like this, so that we have a clear view of the buttons and the LEDs. And with this, our circuit is complete and we can look at writing the code. So I have opened my Raspberry Pi on VNC Viewer over here. We can begin by creating a folder. So this is where we were putting all our code throughout this tutorial series. So I'll create a new folder now, and let's call it Reflex game. And before we proceed any further, and I forget to do this, I'll add this to the CMake list. So I'll add a subdirectory reflex_game so that the compiler knows to compile it. Now we can cd into the Reflex game and start writing our code. So we'll begin by including all the header files that we require. Now we can declare the button and LED pin as an array. We can now take a variable to tell us when the timer was fired. I'll explain this in a bit, but we need a variable called timer fired, and we'll declare that as false. The reason I have declared it as a volatile variable is because the value of this variable will be changed in a callback function in the timer callback function. So this is just to tell the compiler to not put any sort of optimization on this variable, because the value of this variable can be changed outside of the scope of the current of wherever the code currently is. So that is why I've put volatile over there. Then we can write callback. We'll be using a repeating timer. So basically how we'll be doing this is we'll randomly generate a number, light that LED, and start a timer to wait for the button to be pressed, so that we can keep a track of whether the person pressed the button in time or not. If the timer elapses before the button was pressed, then the user has failed and they'll have to start all over. So we'll use a callback for that. I have discussed all of these concepts that I am using in this video in the previous videos in this series, so make sure you check them out. I'll leave a link to them in the description down below and in the cards above. So we'll have a repeating timer callback, and this takes a structure repeating timer underscore t and a pointer to that. So in a callback, we can set the variable of set the value of the variable timer fired as true, and then return true. This is all we need to do. We'll just set the value of the global variable so that we can track it from our main loop and just return true. Now we can go to our main function, and before I forget to do this, we'll return 0 in the end. This will be an infinite loop, so the main function will never really return, but it's always a good practice to return from a non-void function. So the first thing we have to do is stdio init all. This is the same as discussed in all the videos till now. This is so that we can have serial prints. So we can just begin by printing reflex game on the serial. Then we'll create the repeating timer. There is an extra underscore t over here. I'll just remove it. It is only struct repeating timer, no underscore t. And we can call our object timer. Then we use the function add repeating timer milliseconds, and we can give it a time of 1 second now. So we'll give the user 1 second to press the button after the LED glows. It's a bit high, but you can change this number depending on how difficult you want it to be. You can reduce it to 500 milliseconds if you want to give the user only 500 milliseconds. Then the callback. Then the third parameter is user data, which is going to be null for us. And then a reference to the timer itself. Then we can have a variable to track the score of the person. Can initialize it to 0. Then another variable to track the index of the LED that is active right now. Then we can begin by setting up all our GPIO. So we can use a for loop for this because we have a lot of pins to initialize. So first let us set up the LED pins. So we do GPIO init LED pins of I, and then the set direction function. So we'll set them to be output pins. GPIO set direction for LED pins of I to GPIO underscore out. So we're declaring them as output pins. Then in the same loop, we can set up the button pins. So button pins of I. So first we initialize the GPIO. Then we set the direction. And then we set internal pull-up. And with this, all our pins should be set up. We can then call the function srand with time 0, and this basically initializes the random seed for the random function that we'll be using later to generate the index of the pin randomly. So we'll light up these LEDs in a random order. So to initialize the random seed and have random numbers that are not the same every time, we use this function. Then we have our main game loop. So this is going to be an infinite while loop, and our entire game logic is going to be inside it. First thing that we have to take is a variable called button pressed, and we'll consider it to be false. So we have to detect whether or not the user was able to press a button. We'll initialize it to false because we'll assume that they have not been able to yet. Then we'll turn on the LED. But first we have to take the index from the last loop and turn it off. I'll just explain this in a bit. I'll write this section and then I'll explain it to you. So what we do over here is we begin by assuming that the button is not pressed. We then turn off the LED at the LED index position. In the first loop, this does not have much significance because all the LEDs are already off. But in the next loop iterations, what will happen is we generate a new LED index, which we want to turn on. We just print that we're firing that LED. Then we turn that LED on. And in the next loop iteration, before we generate another random number, we turn that LED off from the previous cycle. So that is why we have this line over here. So then we turn on the new LED that we have generated and we wait for the timer to fire. So we say while not timer underscore fired. So at most we will wait until the timer fires. We might exit before also if a button was pressed. So that is what we're going to do now. If not, I'm putting a not over here because as you can see these are active low buttons. I've connected one into ground and put an internal pull up. So if not, GPIO get button pins of LED index. So if the button at the same position as the LED that is glowing, so that's why I'm using the same LED index variable, because the button corresponding to the same LED has to be pressed. So if that button gets pressed, what we can do is set the variable to true, and we can break from the loop. Yeah, then we can simply break from the loop. And what we can do over here is put a sleep underscore ms of 20 milliseconds, just so that this loop doesn't happen too fast and we don't pull the button pin too quickly. 20 milliseconds is a good enough time to wait. You can reduce this if you want. Now outside this loop will come if either the timer has fired or the button has been pressed. So we need to check what exactly happened. So if button was pressed, so if button pressed, then we can turn the LED off immediately. So this is to give a little bit of feedback to the user. So we can say GPIO put LED underscore pins of the LED index as 0. Anyways, in the beginning of the cycle, the LED is getting turned off. But if you press the button, I'll turn off the LED immediately so that it gives like a small feedback to the user that you press the correct button. Otherwise, the user might keep pressing key, why isn't it turning off? Then we can print a small message saying you got it, anything. And then we can increment the score. So the user score will be incremented every time they get it right. And then we can have an else block. So if we are outside of the while loop, which means that the timer got fired, but the button was not pressed, in that case, we can just printf, or you missed anything. Put any message you like. I'll just put a new character at the end over here so that it's a bit neater. You see on the minicom, and I misspelled score over here. So the name of the variable is score. And every time the user misses, we will restart the score from 0. If you want, you can put score minus minus over here. So every time you miss an LED, your score reduces by 1. Or I'll make this game a bit more difficult and I'll make it reset to 0 every time you miss. Then we can simply wait for the next cycle to start. So what this while loop will do is, in case that the user had pressed the button, but there's still a little bit of time remaining in the cycle to finish, we'll just wait here. So we'll call this type loop contains function. I explained this in my last video, but basically this is so that our callbacks get called on time. And then in the end, we can reset the timer fired variable to false. So this is what our main loop is going to look like. I hope you've been following me till here. Let us go ahead and build this and see if it even works. So I'm going to save it. And now we need a CMake list file. So I'm going to copy. Let's see, where can I copy from? Let's take timer tutorial, because a lot of the things from the timer tutorial are going to be used over here. So we'll copy over the CMake list file and edit it however we need. So first of all, we have to replace all of these with Reflex game. I'll just copy paste these everywhere. Now these libraries seem sufficient to me. So we have the stdlib, we have hardware GPIO, and we have hardware timer. So this looks about right. This is all we need. So I'll save it. Now we can go to the build folder, cmake dot dot, and wait for it to build. Okay, and we have the Reflex game available over here. You can go here and run the make j4 command, and hopefully we don't have any bugs. While that is running, I'll connect the Pico in programming mode to my Raspberry Pi. Okay, we have a small exception, and I understood what I've done. Okay, we have two of these issues. I seem to have missed a semicolon somewhere, and I have not given enough arguments to GPIO set direction. I forgot to give the second parameter which says GPIO out. So let me go back to the Reflex game. Yeah, forgot the semicolon. What else? Yeah, set direction. I have to set this as GPIO in, because these are going to be input pins. Let's run the make command again, and hopefully it builds. Yes. Meanwhile, my Pico has connected. So as soon as this is done, I'll copy over the UF2 file to the Pico. Alright, so if I ls, you can see we have the Reflex game UF2 file. So I can copy it over to media pi rpi2. As soon as I do that, yeah, and as you can see, we already have the LEDs glowing in a random order. Let's open Minicom. So you said you can see it's firing all the different LEDs, and I'm missing all of them because I'm not playing yet. Let's start playing. And as you can see, it's printing "you got it" every time I press the button on time. And you can see when I stop pressing, it says, "Oh, you missed." Now there's one thing which we forgot. So I'll go back into my game. We also need to print the score, otherwise the user has no idea what the score is. So let us go back over here, and at the end of each round, let us print your score is %d score. We can build it again, and while it's building, I'll connect it in programming mode. There. Okay, it's done building. I can bring up the copy command and copy it over. Then we can use Minicom. Okay, so I missed the new line character. Let me quickly go and add that. And I'll remove some of these print statements now, because they're crowding up, they're simply crowding up the terminal. So we don't need to know what LED we are firing, we can already see it over here. We can print whether you got it or oh you missed. That is fine, we can keep that. And we can keep the score. So that should clean things up a little bit. We'll upload it back. And let's go back to Minicom, and as you can see, my score is getting reset to 0 because I'm missing every single one of these. So let's start playing. Okay, as you can see, my score is going up, and it is telling me whether I hit it or missed it. Let me miss on purpose now. You can see it says, "Oh, you missed," and my score resets back to 0. You can try reducing the time if you wish. That will make the game even harder to play. So in order to do that, you can change this. So if I change it to 500, I have half the time now to press the button. and you can keep playing around with this number until you reach a value which you're comfortable playing with. Okay. As you can see already, the LEDs are jumping around much faster now. Let's see if I can keep up. Okay, this is really fast. As you can see, my score is going up, and now let me miss on purpose and it resets back to 0. Now what will be more fun is if we make this game a bit adaptive. So the more you get right, the faster it gets. But that is for the next video. So that's all for this video, guys. I hope you enjoyed it. I hope you learned something today, and if you did, do leave us a like and comment down below if you have any queries, ideas or suggestions that you may want to share with us. Don't forget to subscribe, because in the next video I'll add a few features to this, like we'll make it a little adaptive. So the more you get it correct, the faster the game will become. So stay tuned for that one. Until then, keep learning, keep programming, and I'll see you in the next one.